Imagine asking an AI question and trusting its answer. But how accurate is artificial intelligence really today? Many people assume AI always knows the correct answer. The truth is more complex than most people expect. AI does not think like humans at all. Instead, it predicts words based on massive data patterns. These predictions can be right or sometimes completely wrong. Understanding accuracy starts with understanding how AI actually works. AI systems learn from enormous datasets collected online. These datasets include books, websites, and digital conversations. The AI studies patterns between words and sentences carefully. It then uses probabilities to generate new responses. This means AI is guessing, not truly understanding meaning. Yet those guesses often appear surprisingly intelligent and precise. Accuracy depends heavily on quality of training data used. If data contains errors, AI can repeat those mistakes. This is why misinformation sometimes appears in AI answers. Developers constantly try improving datasets for better reliability. However, perfect accuracy remains impossible with current technology. Another factor affecting accuracy is model size and design. Larger models often perform better on complex questions. They recognize more patterns across broader knowledge areas. But even large models can confidently give wrong answers. This issue is known as hallucination in AI systems. Hallucination means generating information that sounds correct but false. It remains one of the biggest challenges in AI. Users must therefore verify important information independently always. AI is best viewed as a helpful assistant tool. It supports thinking, but should not replace critical judgment. Accuracy also varies across different types of questions asked. Simple factual questions are usually answered more correctly. Complex reasoning tasks increase chances of mistakes significantly. Mathematical or logical problems still require careful validation. Some AI systems are fine-tuned for specific domains. Medical or legal AI requires stricter accuracy controls. Even then, professional oversight remains extremely important always. Another key concept is training bias in data. If data is biased, AI responses can also reflect bias. This affects fairness and accuracy in subtle ways. Developers work continuously to reduce these harmful biases. Transparency helps users understand AI limitations better overall. Knowing limitations improves how effectively AI can be used. AI does not have real-time awareness of truth. It cannot verify facts unless connected to updated sources. Most models rely on static training datasets. This creates gaps in recent or changing information. Therefore, outdated knowledge can reduce accuracy significantly sometimes. Users often misunderstand AI as an all-knowing system. In reality, it is a prediction-based language engine. That difference is critical for understanding reliability properly. Another important factor is prompt clarity from users. Clear questions usually produce more accurate answers overall. Vague prompts can lead to confusing or incorrect outputs. How you ask questions directly impacts AI performance quality. Context also plays a major role in accuracy. More context helps AI generate better relevant responses. Without context, AI must guess user intentions instead. This increases chances of misunderstanding or error significantly. Despite limitations, AI still offers powerful capabilities today. It can summarize, explain, and generate useful information quickly. Many industries rely on AI for productivity improvements. Businesses use AI for data analysis and automation tasks. Students use AI for learning and concept explanations. Writers use AI for brainstorming and content creation support. However, human review remains essential in all cases. Combining AI output with human judgment produces best results. Think of AI as a very advanced calculator. It processes information but does not truly understand it. Accuracy improves when humans guide its usage carefully. Misuse or blind trust can lead to serious mistakes. Responsible use is key to benefiting from AI systems. Understanding how AI works improves decision-making skills greatly. Knowledge reduces fear and unrealistic expectations about technology. Next, we explore real-world AI accuracy challenges deeply and how errors happen in practical situations daily. AI accuracy becomes most visible in real-world applications. Everyday users often notice mistakes during practical usage. These errors help reveal how AI systems truly function. One major challenge is understanding context correctly every time. Humans rely on experience to interpret meaning accurately. AI relies only on patterns learned from data. This difference often leads to misunderstandings in responses. Even small changes in wording can affect results greatly. A question phrased differently may produce completely different answers. This inconsistency confuses many users expecting stable accuracy. Another challenge is ambiguity in human language itself. Words often have multiple meanings depending on context. AI must guess which meaning is intended carefully. Sometimes it selects the wrong interpretation entirely. This leads to answers that seem correct, but are not. Real-world data also contains noise and contradictions. AI learns from this imperfect and messy information. As a result, conflicting answers can emerge occasionally, though. Training data quality directly impacts output reliability significantly. Clean, structured data improves AI performance noticeably over time. However, internet data is often unverified and inconsistent. This creates challenges for maintaining high accuracy levels. Another issue is overconfidence in generated responses sometimes. AI systems may present uncertain answers in confident tone. This makes incorrect information harder for users to detect. Developers work on calibration techniques to fix this issue. Still, perfect confidence alignment remains an ongoing challenge. AI lacks true understanding of truth or reality. It cannot independently verify facts against real-world evidence. This limitation affects reliability in critical situations strongly. Medical advice generated by AI requires expert verification always. Legal interpretations also need professional human review carefully. Financial predictions from AI can be highly uncertain. These areas demand high precision and accountability levels. Another factor influencing accuracy is model training updates. Older models may lack recent world information entirely. This leads to outdated or irrelevant responses sometimes. Continuous retraining helps improve relevance and correctness gradually. However, updates are not always immediate or frequent. Therefore, temporary knowledge gaps still exist in systems. User behavior also impacts perceived AI accuracy significantly. Poorly structured prompts often produce weaker results overall. Clear instructions guide AI toward better responses consistently. Providing context improves understanding and reduces confusion greatly. Many users underestimate importance of prompt design skills. Effective prompting significantly improves output quality and reliability. Another issue is hallucination in generative AI models. Hallucination refers to AI inventing false information confidently. These outputs may look realistic, but lack factual basis. Detecting hallucinations requires careful human evaluation and judgment. This remains one of AI's most studied problems today. Researchers continuously develop methods to reduce hallucination frequency. External tools like search integration improve factual accuracy. However, standalone models still struggle with real-time facts. Another limitation is inability to understand lived experience. AI cannot personally verify events or physical reality. It only processes textual representations of information available. This creates a gap between language and reality. Despite limitations, AI still performs impressively in many tasks. It can summarize large documents in seconds efficiently. It can generate ideas faster than human brainstorming sometimes. It can assist with learning and explanation effectively. These strengths make AI valuable despite accuracy limitations. The key is using AI appropriately for each task. Not every task requires absolute factual precision always. Creative and supportive tasks benefit greatly from AI assistance. Critical decision-making requires additional verification steps always. Balanced usage improves outcomes and reduces risk significantly. Understanding limitations helps users avoid unrealistic expectations. AI is powerful, but not infallible or perfect. Its performance depends on data, design, and usage. Human oversight remains essential for reliability and safety. Responsible use ensures better results across all domains. Next, we explore how accuracy is measured scientifically and what metrics define AI performance in practice. Measuring AI accuracy requires more than simple right or wrong. Researchers use multiple metrics to evaluate model performance carefully. One common metric is accuracy percentage on test data. This measures how often predictions match correct answers overall. However, accuracy alone does not capture full model behavior. Another important metric is precision in specific predictions. Precision measures how many positive predictions are actually correct. High precision reduces false positive errors in results. Recall is another key evaluation metric used widely. Recall measures how many actual correct items are found. Balancing precision and recall is often necessary in systems. This balance is known as F1 score in AI. F1 score combines both precision and recall into one value. It helps evaluate models more fairly across tasks. Different applications require different evaluation priorities and thresholds. Medical systems often prioritize recall to avoid missing diagnoses. Spam filters may prioritize precision to avoid false alerts. Therefore, accuracy depends on context and intended usage goals. Another evaluation method involves benchmark datasets for comparison testing. These datasets contain standardized questions with known correct answers. Models are tested against these datasets systematically and repeatedly. Performance results help compare different AI systems fairly. However, benchmarks may not reflect real-world complexity fully. Real-world language is more messy and unpredictable than datasets. This creates gaps between test accuracy and actual performance. Another concept is confidence scoring in AI predictions. Confidence indicates how certain the model is about output. However, confidence does not always match actual correctness. High confidence can still accompany incorrect answers sometimes. This mismatch creates risks for trusting AI blindly. Calibration techniques aim to align confidence with accuracy better. Well-calibrated models provide more reliable probability estimates. Another factor is dataset bias influencing evaluation results. Biased datasets can artificially inflate or reduce accuracy scores. This makes fair evaluation more challenging for researchers. Cross-validation techniques help reduce overfitting in testing. Overfitting occurs when models memorize training data too closely. Such models perform poorly on new, unseen data. Generalization ability is therefore crucial for true accuracy. Good models perform well across diverse real-world situations. Another measurement approach involves human evaluation of outputs. Humans rate responses based on correctness and usefulness. This adds subjective judgment to technical evaluation methods. Human feedback helps improve model alignment over time. Reinforcement learning uses this feedback for training adjustments. This process improves response quality gradually and continuously. However, human evaluation can vary between different reviewers. This introduces some inconsistency into scoring systems. Another challenge is multilingual accuracy across different languages. AI models perform better in languages with more data. Low-resource languages often show reduced accuracy levels. This creates global inequality in AI performance quality. Researchers are working to improve multilingual capabilities continuously. Another factor is domain-specific accuracy differences across fields. AI may perform well in general topics, but struggle. Specialized domains require fine-tuned training for better results. Without tuning, accuracy drops in technical subjects significantly. Continuous learning systems aim to improve over time. However, most models are still trained in fixed cycles. Real-time learning remains a complex technical challenge. Evaluation also considers robustness against adversarial inputs. Small input changes can sometimes mislead AI systems. Robust models resist such manipulation more effectively overall. Security researchers study these vulnerabilities extensively in AI. Another key metric is latency in generating responses. Fast responses improve usability, but may affect depth. Trade-offs exist between speed, cost, and accuracy always. Developers must balance these factors carefully during design. No single model optimizes all metrics perfectly together. Each system is built for specific performance priorities. Understanding metrics helps users interpret AI results better. It also prevents unrealistic expectations about performance. Accuracy is therefore a multidimensional concept in AI. Next, we explore future improvements in AI accuracy and how technology may reduce errors over time. AI accuracy continues improving rapidly with new research advances. Developers constantly work on reducing errors in model outputs. One major improvement area is better training data quality. Cleaner data sets help models learn more reliable patterns. Data filtering removes noise and incorrect information sources. This significantly improves prediction stability across tasks. Another advancement is retrieval augmented generation technology. This allows AI to access external verified information sources. It reduces reliance on outdated internal training data. Real-time search integration improves factual accuracy significantly. However, external sources must still be carefully validated. Not all online information is reliable or correct. Therefore, filtering and ranking systems remain extremely important. Another improvement is reinforcement learning from human feedback. Human reviewers guide models toward more accurate responses. This feedback loop improves alignment with human expectations. It also reduces harmful or misleading outputs gradually. Model architectures are also becoming more efficient over time. New designs improve reasoning capabilities in complex tasks. Chain-of-thought reasoning helps models break down problems. This leads to more structured and accurate responses. However, reasoning can still produce incorrect conclusions sometimes. Therefore, verification remains important even with advanced models. Another improvement area is multimodal AI integration. Models now process text, images, audio, and video together. This expands understanding and improves contextual accuracy overall. Multimodal systems reduce ambiguity in complex, real-world inputs. Another key advancement is longer context window processing. Models can now analyze much larger text inputs. This helps maintain consistency across long conversations. It also improves accuracy in document-level understanding tasks. However, memory limitations still exist in current systems. Continuous research aims to extend context even further. Another innovation involves specialized domain-specific AI models. These models are trained for medicine, law, or science. Specialized training improves accuracy in those specific fields. General models still struggle with technical precision sometimes. Hybrid systems combine general and specialized models together. This improves performance across multiple application areas significantly. Another development is better uncertainty estimation techniques. Models can now express when they are unsure. This helps users interpret responses more cautiously. It reduces blind trust in incorrect outputs. Improved calibration makes confidence scores more meaningful. Another important trend is continuous model evaluation systems. Models are tested regularly on evolving benchmark datasets. This ensures performance does not degrade over time. Automated monitoring detects accuracy drops early. Developers can then retrain or adjust models quickly. Another area of progress is bias reduction techniques. Researchers actively work to make outputs more fair. Reducing bias also improves overall reliability and accuracy. Diverse datasets help achieve better generalization results. Another advancement is synthetic data generation for training. Synthetic data helps fill gaps in real-world datasets. This improves coverage of rare or missing scenarios. However, synthetic data must be carefully validated too. Another improvement involves better error correction systems. Models can now self-correct during response generation. This reduces obvious mistakes in outputs significantly. Feedback loops help refine answers dynamically in real time. Another development is improved computational efficiency in training. Faster training allows more frequent model updates overall. This leads to faster improvement in accuracy levels. Cloud-based AI systems enable scalable model deployment easily. This allows continuous improvement across millions of users. Despite progress, perfection remains unreachable in AI systems. Complexity of human language ensures ongoing challenges persist. Real-world unpredictability always introduces uncertainty into outputs. Therefore, AI will always have some error margin. The goal is minimizing errors, not eliminating them completely. Responsible design focuses on safe and reliable usage. Users must still apply critical thinking when using AI. Technology improves constantly, but caution remains necessary always. Next, we conclude with final insights about AI accuracy. AI accuracy ultimately depends on both technology and users. Even the most advanced models require responsible human guidance. Understanding limitations is key to using AI effectively. AI should never be treated as absolute truth source. Instead, It works best as a supportive intelligence tool. Users who verify information achieve better results consistently. Critical thinking remains essential in every AI interaction. Technology alone cannot guarantee perfect correctness in outputs. Human judgment adds necessary context and validation always. The future of AI accuracy looks promising but complex. Continuous improvements will reduce errors over time gradually. Better training methods will enhance reliability significantly worldwide. However, uncertainty will never fully disappear from AI systems. This is due to language complexity and ambiguity. Real-world knowledge constantly changes and evolves rapidly. AI must continuously adapt to keep up with change. Future systems may integrate real-time verified knowledge sources. This could dramatically improve factual accuracy in responses. Stronger collaboration between humans and AI will emerge. Humans will guide interpretation while AI handles processing. This partnership model increases productivity and reduces errors. Education about AI will become increasingly important globally. People must understand both strengths and weaknesses clearly. Misunderstanding AI leads to misuse and misinformation risks. Proper training helps users maximize AI benefits safely. Transparency in AI systems will also improve trust. Users may eventually see clearer explanations of reasoning. Explainable AI will help users understand decision pathways. This improves accountability in critical applications significantly. Healthcare, finance, and law will benefit greatly. These fields demand high accuracy and reliability standards. AI will assist professionals rather than replace them. Human expertise remains essential in all major decisions. Automation will continue expanding across industries worldwide, but oversight will always remain necessary for safety. Ethical guidelines will shape future AI development strongly. These guidelines ensure responsible use of powerful systems. Governments and organizations will enforce stricter regulations. This will improve safety and reduce harmful outputs. However, innovation must continue alongside regulation carefully. Balancing progress and safety remains a global challenge. AI accuracy will improve through collaborative global research. Scientists continuously share findings to advance the field. Open research helps accelerate improvements across all systems. Community feedback plays a vital role in development. Users help identify errors and improve future versions. This feedback loop strengthens AI systems over time. The journey toward better accuracy is ongoing always. There is no final destination in AI development. Only continuous refinement and learning exist ahead. Understanding AI today prepares us for tomorrow's tools. Knowledge empowers better decisions in digital environments. Awareness reduces risks associated with incorrect assumptions. AI will remain imperfect but increasingly powerful. Its usefulness depends on informed and careful usage. Combining human intelligence with AI creates strong outcomes. Neither works optimally without the other fully. The future belongs to collaborative intelligence systems. Where humans and AI complement each other effectively, accuracy will always improve, but never become perfect. That limitation defines the nature of intelligent systems. Accepting this helps build realistic expectations about AI. Users who understand this gain significant advantage. They use AI more safely and effectively overall. The evolution of AI is still in early stages. Future breakthroughs may change how accuracy is defined. For now, careful use remains the best approach. Learn, verify, and question every important AI output. Treat AI as a tool, not authority. This mindset ensures safer and smarter decisions always. AI will continue shaping the digital future ahead. Its accuracy will steadily improve with time. But human responsibility will never disappear completely. Together, humans and AI can achieve great progress. And that is the true future of intelligence.